So the task at hand is to find integers s and t such that s times a plus t times b equals the greatest common divisor between a and b. Okay, for integers, again, a and b are integers. So the first task, of course, between those integers is to find the greatest common divisor. And then once we have that, then we've seen it as working backwards, working the Euclidean algorithm backwards, calling it the extended Euclidean algorithm, to find these values s and t. So let's look at this in another way. Let's study this example, GCD between, we'll say, 296 and 124. So we do have to carry out the Euclidean algorithm to actually find the GCD, and it's not just a matter of getting the GCD that's important, it's the process that we're going to need to still reference. So first thing we need to ask ourselves is, how many times does the smaller value go into the bigger value? And then what remainder does that leave? Well, I can see that that goes in twice. 2 times 124 is 148, and that means there's a remainder of 48, since 48 plus 48 equals 96. Okay, so now we know that the GCD between 296 and 124 is the same as that between 124 and 48. And so once again, I'm going to ask myself, how many times does 48 go into 124, and what remainder does it leave? Well, I can do it twice. I can't do it 3 times. 2 times will give me 96. And I believe that's going to give us a remainder of 28. Okay, so just going to check that. 124 minus 96, I always make a mistake here, is 28. Okay, again, the GCD between 124 and 48, its divisor, is the same as the GCD between the divisor and the remainder. So 48 is equal to some number of multiples of 28 plus a new remainder. Well, 28 only goes into 48 once, leaving a remainder of 20. And the GCD between 48 and 28 is the same as that between 28 and 20. 20 goes into 28 one time, leaves a remainder of 8. And now working on 20 and 8. Okay, 8 goes in twice, leaves a remainder of 4. And I'm just about done here. Now between 8 and 4, well, 4 goes into 8 2 times and leaves a remainder of 0. So my greatest common divisor is equal to 4. All right, now at this point, I know that 296 and 124 are my A and B. So what I'm going to do is I'm actually going to reference these values as A and B. And in fact, if you look at the first equation here, this one suggests that A is equal to 2 times B. Okay, so this is A, this is B. So we're going to actually, anywhere we see 296 and 124, we're going to represent those with A and B. Okay, so I actually get now an algebraic equation. And now it's going to be a little bit easier to manipulate because now I'm going to be working with A's and B's and I can focus on combining like terms. In the second equation, I have B is equal to 2 times 48 plus 28. Okay, now this is still where it's tempting to write this as B is equal to 124, which it is. But now I'm actually going to start with this second line, and instead of working backwards, we're going to continue working downwards until we get to the end. So b is equal to 2 times 48 plus 28. So what I'm going to do is I'm going to solve for the remainder in here. So if I subtract 2 times 48, I'll have 28 equals b minus 2 times 48. Now the key here is don't multiply them out, because now I have the ability to substitute. In this first equation right here, we're going to write that 48, again, solve for the remainder, is equal to a minus 2b. All right, so that's the setup, the initialization. The first two lines of the Euclidean algorithm give you a and b, because once again, 124 is the value of b. And that's all the substitutions that we can make with our quantities. All right. So then the second step is let's solve for the remainder in the first two lines. And now we're going to do forward substitution. So in other words, notice that 48 I can express in terms of a and b. Okay. So this means that 28 is equal to b minus 2 times the quantity a minus 2b. Ooh, we kind of like this because now it's simply algebra, and we get b, and we'll distribute the negative 2. We'll have negative 2a plus 4b. We'll now combine like terms, so this gives us 28 equals negative 2a plus, and we have 1b here, 4b, so we have 5b. Okay, so it's no different than using x and y. And so now we have what 28 equals. We've combined the first two steps. Well, now we need to move to the third line. Okay, so in the third line, if we now represent that in terms of its remainder, that's going to be 20 equals 48 minus 1 times 28. Okay, so we can already see where we're going to end up making substitutions. First of all, we see that 28 is equal to this line that we just wrote. And also, we note that 48 is equal to the original thing we wrote down. So once again, we just get to substitute out the two quantities, namely the dividend and the divisor both get to be written out in terms of a and b. Okay, so here we go. Let's get back at it. So 20, maybe I'll go ahead and write this down here. 20 is equal to 48, which is a minus 2b, minus 1 times 28, which is negative 2a plus 5b. And again, we're just going to combine like terms, so it just becomes algebra. We'll have a minus 2b, distribute the negative 1, we'll have plus 2a minus 5b. And this gives us, after we combine like terms, it gives us 3a minus 7b. Now, just as a quick check along the way, if I take 3 times my a value, 3 times 296, minus 7 times my b value, which is 124, I should ensure that I get 20, which I do. If I didn't get 20 when I carried out this operation on a and b, I know I made a mistake somewhere in my substitution. Well, guess what? Now it continues on, and now my previous two substitutions will take place. So notice that in this next line, we have 20 and 28. And I'm going to take just a moment here before we proceed with that next step, just to highlight what substitutions we're making in each of these lines. So notice that here in this 20 line, we made substitutions for 28 and 48. In this next line, we're going to make substitutions for 20 and 28, and then 8 and 20. And that's really going to be our last substitution. We don't need to go on to this last line because that will already give us some combination of A and B equals 4, right? Because when we solve for 4 in this line here, we'll get 4 equals, and that's exactly what we're hunting for. So this just makes it a lot easier, I think, to keep things organized. So let's move to the next line. 8 is equal to 28 minus 1 times 20. And as we said before, we're going to substitute 28, which is equal to negative 2a plus 5b, 20, which is equal to 3a minus 7b. So doing this highlighting here helps us keep track of that neatly. And so I'm just going to carry this down here. And so we have 8 is equal to 28. Okay, 28 is equal to negative 2a plus 5b. So all I've done there is just replaced 28 with what it is equal to. Minus 1 times 20, well, 20 is equal to 3a minus 7b. Okay, combine like terms, negative 2a plus 5b, distribute the negative 1. That gives me this quantity, and I get 8 is equal to negative 5a, combining like terms, plus 12b is equal to 8. Now, just to check my work once again, I can do negative 5 times 296, which is my value of a, plus 12 times 124, which is my value of b, and lo and behold, we get 8. So everything is good so far. Our last line now entails solving for 4 here. 4 is equal to 20 minus 2 times 28. 2 times 8, excuse me, which is a true statement. And so now I'm going to make my final substitutions. What am I going to substitute out? Well, the 20 and the 8 is what I'm going to substitute out. And I've highlighted that to make it evident. So I can just kind of go down now. So 4 is equal to 20. 20 is 3a minus 7b. Minus 2 times 8. 8 is negative 5a plus 12b. And this gives me 4 equals 3a minus 7b plus 10a minus 24b. And so if I combine like terms, I get 4 is equal to 13a minus 31b. In other words, now that we're done, this is the GCD between A and B. That is the GCD between A and B. So if I rearrange this, I can say that it's 13 times 296 minus 31 times 124 that gives me my GCD. So 13 is my value of S, and negative 31 is my value of t. That is a very algebraic way to go about doing this without having to worry too much about what it is that we're keeping track of, because we get to use substitutions, and then when we're combining like terms, we don't have to worry about accidentally combining things and multiplying things out that we weren't supposed to, because there's only so far we can go with having terms containing A and terms containing B. So to kind of recap, circle back to the top, the first thing we did is the first 2 lines gave us expressions for A and B. So anywhere we had a 296 or a 124, we put in an A and a B as appropriate. Once we had that, then we started in the second line, solved for the remainder, and then for 124 and 48. For 124 and 48 made substitutions. Actually, we already had 124 was B. Then for 48 we put in A minus 2B, got that first line. And now move to the third line in the Euclidean algorithm, solve for the remainder, substitute in our two previous 48 and 28, get a new expression, and now that gives us an expression for 20. So in this next line, when we write 8 equals 28 minus 1 times 20, we use the two previous substitutions, 28 and 20, to plug in there, got a new expression, then went to solve for the last line being the one before we get a zero remainder, because that's going to give us that remainder is the GCD, and we're able to package it all together nicely.